Electrochemistry. Electrochemistry deals with the chemical changes produced by electric current and with the production of electricity by chemical reactions. An example could be a lemon battery, in which we could generate voltage and light up a little LED bulb through this fruit. By inserting two metals into the lemon and connecting them in a series, we could generate a voltage. An electrochemical cell can be used to generate electricity via redox or oxidation-reduction reaction. A redox reaction refers to the chemical reaction in which one or more electrons are transferred from one atom or molecule. But it can also facilitate chemical reaction through the use of electricity. There are two types of electrochemical cells: the galvanic cell, which generates current, and the electrolytic cell, which acquires current. Let's talk about galvanic cells. The galvanic cell can also be referred to as a voltaic cell. It was named after two Italian physicists in the 18th century, Alessandro Volta and Luigi Galvani. The galvanic cell generates electricity using the energy that is released from a spontaneous redox reaction. Now, let's move on to the electrolytic cell. In an electrolytic cell, electricity from an external source causes non-spontaneous chemical reactions to occur. Lysis means splitting apart. Compounds are split into their constituent elements in many electrolytic cells. For instance, the splitting of water, H2O, into H2 and O2 gases. An example of this type of electrochemical cell is a rechargeable battery. It acts as an electrolytic cell when you plug it to a source of electricity. It stores energy. As soon as you plug it out, it will then be a galvanic cell that can generate current or release energy. Most, if not all, electrochemical cells are built using a liquid called an electrolyte, which is a solution that contains ions. Electric current is produced at the motion of ions through a solution. Positively charged ions migrate towards the negative electrode, and negatively charged ions migrate towards the positive electrode. An electrochemical cell has two parts. Each part has one electrode, which is an ionic substance connected to an external circuit that provides an electric connection between the two parts of the system. The electrode at which the oxidation occurs is the anode. It strongly attracts anions, or the negative ions, which means that it is positive. The cathode, on the other hand, is negative and is where the reduction occurs. Having trouble remembering? Here's a tip. Always imagine a red cat and remember that reduction takes place at the cathode. The electrons flow from the anode to the cathode. The potential difference between the electrodes causes electrons to flow from the reductant to the oxidant, thus generating electric current. In an electrolytic cell, an external source of electrical energy is used to generate a potential difference between the electrodes, which forces the electrons to flow, and thus gives a non-spontaneous redox reaction. You'll see in this figure the electrolysis of molten sodium chloride NaCl to produce Na and Cl2. For demonstration, a zinc rod is inserted in a zinc sulfate solution, and a copper rod is inserted into a copper sulfate solution. When the circuit is complete, the anode, which is the zinc electrode, is spontaneously oxidized to zinc 2+ ions, while copper 2+ ions are simultaneously reduced to copper metal at the cathode, which is the copper electrode. Thank you for watching.